These problems now involve stoichiometry with the enthalpy of change. So notice how stoichiometry is pervasive. It's everywhere because we're dealing with the amount. The amount and heat are related. So it says here, if 5.25 grams of methane are used in the reaction above, how many kilojoule of heat would be released? Okay, so when you look at this equation, and let's just get some more space here. You need to use stoichiometry along with, of course, the amount of heat given here. Okay, so we said this is for 1 mole. This is how much heat would be released if you have 1 mole of methane and, of course, 2 moles of oxygen. Now it says to you have 5.25 grams of methane. So let's start. So we say, okay, 5.25 grams of methane. And it says how many kilojoules of heat, meaning we need to end with kilojoules of heat. This is entirely new to you, but it's very doable. So here's how we would set up our equation. Remember, when we deal with grams in stoichiometry, we have to convert them to moles. So that means I have to go from the moles, the grams of CH4 to the moles of CH4. So in this case, that would be 16.05 grams of CH4, which is 1 mole of CH4. So where did this come from? This is the molar mass from the periodic table. Now notice that the unit cancels out, but then how do we get to the next step? Well, this is how you would read it. Here it says 1 mole of CH4 is responsible for negative 890 kilojoules of heat, or the release of 890 kilojoules of heat. So that means that here's my other conversion factor. 1 mole of CH4, they need to cancel out, is negative 890 kilojoules. And then they would cancel out like that. So if you do this calculation, you would get of course, the negative sign will remain. You will get negative 291 kilojoules. Makes sense because this is less than 16 grams. If you had 16 grams of methane, you would release 890, but here you only have 5.25. So what you should be doing is, before we meet next time, is do this problem. Now it's asking you for the opposite. It's asking you, if you're given the heat, how many grams of O2 would be used. Pay attention when you do this problem to the ratios. Pay attention to that.